So welcome to this talk from pirates to quests to voyages and beyond. I'm going to talk about Lynn's impact on word problem solving. And my name is Sarah Powell, and I'm a professor at the University of Texas at Austin. But I haven't always been in Austin, Texas. And so I realized yesterday Pam was one of Lynn's first doc students to talk. And Daniel Espinas, after lunch, is going to be one of Lynn's last doc students to talk. And I came somewhere in the middle. But I also realize I'm not alone, and I do want to recognize that if you were one of Lynn's doc students, I would like you to stand up right now, because there are quite a few of them in the room. Yeah? All right, a lot of them. Thank you. Yeah, they're an amazing group. Yeah, Brittany, Lee, Pam, yeah. And if you ever worked on a Fuchs research project, I would like you to stand up. I think this is going to be about half of the room. Yeah, all right. Wow, this is an amazing, thank you so much. Amazing, yeah, and Paul, yes. So many people have contributed to this work, and I just actually feel honored to talk a little bit about Lynn's word problem solving. And I looked at this picture of Lynn again over on the far right-hand side today, and I was reminded of Doug's comment yesterday about Lynn and her clothing choices, and I just think that is the cutest Lynn Fuchs outfit ever. And that's exactly how I think of her. So I'm going to go back and tell a story about some pirates. So back in the early 2000s, Lynn and her research team were working on work related to word problem solving with a program called Hot Math. And I know Robin Fanelli Schumacher was working on that project, and Carol Hamlet and others. And they were looking at how students set up and solve word problems in grade 3 by problem type, but by looking at common problem types that were represented on standardized assessments. But then Lynn received some funding with Doug and others to more formalize those problem types to reflect what is known in the literature around the word problem schemas. So when students are thinking about addition and subtraction, how do they interpret addition and subtraction? Well, it's putting together, it's comparing, and then it's increasing or decreasing by adding on. So I was working with Pamela Seathaler at the time. This is a picture of us, Pamela, from 2006. I realized you look exactly the same. My hair is about a foot longer now. But Lynn asked us to work collaboratively with her to put together an intervention related to these word problem schemas at 3rd grade. So we spent tons of time in Lynn's office, first even thinking about like what are the schemas, right? It's hard to teach adults the schemas if they're not familiar with them. And Pamela was always much more adept at this than I was. But we started putting together these ideas that we could help students set up and solve word problems by these schemas, use equations to represent the schemas to then hopefully be an easier pathway to problem solving for students. And as we talked about using an equation to set up these word problems, we had this whole idea of using a variable to represent the unknown information. That variable just commonly got marked off as X. And if you're ever talking about X, who likes X? Pirates, right? They're finding that treasure on a treasure map, and so pirate math was born. And so some early versions of this program, Pamela and I, and with Lynn, wrote all of these lesson guides. In the fall, I was here talking about how Lynn edited every single word of every lesson guide we ever wrote for her. Many of you know this. And I remember one time we were writing these lesson pirate math scripts, and on page 342, I wrote in the text, Lynn, are you still reading this? And she wrote a little arrow over to the side in her little cute cursive writing. She said, yes, Sarah, I'm still reading this. But we worked on developing this attack strategy called Run and did just a lot of work on the schemas. And so using these equations to represent these different word problems. And this was our early version of pirate math. And that first study came out in 2008, and then some subsequent randomized control trials that I had the opportunity to lead alongside Pamela came out around 2010, 2011. But it was in this time that Lynn did, I think, one of the most absolutely impactful things in my career was that I was about to do my dissertation, and I had taken a class with BRJ, Bethany Riddle Johnson here, and Bethany just talked a lot about the equal sign. And in pirate math, we were having students set up and solve these equations where they might write 26 plus x equals 72. And I was thinking, based on Bethany's class, and I took this idea to Lynn, and I was so nervous because I was like Kristen, you were always so nervous to take stuff to Lynn, even though she was so supportive. I said, I have this idea that maybe in pirate math, we need to talk about the equal sign with students, because if their equation solving improves, then maybe their word problem solving improves. And Lynn was like, well, all dissertations don't lead to significant effects, but I think it's worthy of investigation. And so she did this thing that I'll share a little bit here today, where we were able to recruit some additional students for my dissertation project and actually investigate that. And it actually did show that understanding the equal sign was an important part of your word problem solving. And then Lynn and Doug and others received funding to move a lot of this work to grade 2. And so this is where Robin comes into play, and Rebecca Zumed-Edmonds, the picture's a little dark, you can see her there, and Pamela and I. And all of us worked with Lynn very collaboratively on taking pirate math from 3rd grade to 2nd grade. But 2 versions of pirate math at this point, pirate math whole class, and then also a pirate math small group. So really a tier 1 and tier 2 program working in tandem. And this, I see, was an early effort at alignment across tiers in math, well before a lot of people were actually talking about how important alignment was. And so we continued this work, and Lynn and her colleagues, Katie and Pamela, have taken this work in pirate math all the way down to 1st grade. But I'm going to now talk about some of the work that I've been doing with word problem solving based on Lynn's research, and now my students are doing that as well. So we are going to move from pirates to quests. So the whole idea around this understanding the equal sign within word problem solving helped me develop this part of pirate math called Equation Quest. And so now we call this Pirate Math Equation Quest. And I tried 3 times to get this funded, and it was funded by IES on the 3rd time with a lot of effort and help from not only Lynn, but also Marcia. And so at 3rd grade, from 2015 to 2020, we were investigating really how important it is that students understand the equal sign and equation solve as part of their word problem solving process. This is one of our tutoring teams for one of these years. That's Kate Berry, who helps me lead so much of this work in the Austin, Texas area. And so we took the original Pirate Math program, and then we compared that to Pirate Math Equation Quest. And so many of the things that we started here at Vanderbilt continued to be done in our schools in the Austin, Texas area, but then we really focused on this Equation Quest aspect over here for Pirate Math Equation Quest. So we talked a lot about what the equal sign means. The equal sign means a balance between 2 sides of the equation, and we help these students just do a lot of practice when they are solving equations with a missing variable. And so we were really interested in whether pirate math not only led to improved word problem outcomes, but whether there was this sequential mediation model that could be modeled. So we were interested in whether students' equal sign knowledge would influence their equation solving, and if that in turn would improve their word problem outcomes. And so in both of the pirate math conditions, we did a lot of the same work that started here at Vanderbilt. We talked a lot about these common word problem schemas, such as total problems, where parts are put together for a total, difference problems, where amounts are compared, and change problems, where amounts increase or decrease. You'll notice on each of these cards, there's an equation, a schema equation, that represents the schema of the word problems. And so this goes back to, well, do students understand that equal sign as balance in not only these schema equations, but in any numerical equations they would construct as well. Here's one of our tutors doing work with some of our students in Austin on the Pirate Math Equation Quest activities, lots of stuff with manipulatives, lots of talk about the equal sign. And what we saw, maybe not surprisingly, is that both of the Pirate Math interventions were very efficacious in terms of post-test outcomes on word problems for students. But importantly, in this study, we did see that this sequential mediation model actually did impact word problem solving. So students in Pirate Math Equation Quest, and only Pirate Math Equation Quest, they did demonstrate improved equal sign knowledge, which in turn improved equation solving, and then that in turn improved word problem outcomes. It's a slight impact, but it is there. So both of the Pirate Math programs are certainly efficacious, but we did see the effect of Pirate Math Equation Quest. And just as with all of the people that stood up earlier, there's a tremendously large team that is able to do this work, and I always thank them. And I also thank the Institute of Education Sciences who funded this work. And so we took a lot of those ideas from third grade, and then we now moved it to fourth grade. And here it gets a little bit more complicated because in fourth grade, we start to think about multi-step word problems. This was the first research team of 3 that contributed very greatly to this work. I think you can probably guess by the picture what year we were in schools because everyone's masked up here. But a lot of the things we did in Pirate Math were helping students set up and solve single-step word problems. So they might use an equation like this to represent this structure. But what happens when students are presented with multi-step word problems? Well, this is a multi-step word problem where I have to put about a bunch of amounts together, and then I have a change in the amount of money that I spent. So I could use 2 equations to represent this word problem. But what if I used 1? And so Lynn and I spent a lot of time on the phone talking about what this might look like if we were to ask students in grade 4 who have math difficulty to set up and solve a singular equation such as the one that you see here. And so in this investigation of Pirate Math, we took pretty much all of the components of Pirate Math Equation Quest, but now we had two different interventions running against each other. And Lynn just loved to do these multiple interventions competing against each other to see which, if any, led to improved outcomes. And so here we tested Pirate Math Equation Quest where students would use 1 equation to represent the totality of a word problem, versus Pirate Math Equation Quest, where students would use multiple equations in steps to represent the different steps or the different schemas. At this point, we started to transition to a different attack strategy to account for that multi-step nature of word problems. So here we're using UPS check squared. And then we also introduced a new schema because that's really important in grade 4. That's the equal group schema. But again, keeping so many things consistent of things that were actually developed 10, 15 years prior. Students who worked with 1 equation, they worked a lot with thinking about how to learn to set up and solve these equations, especially the order of the operations. Again, these are 4th graders who are scoring below the 25th percentile, and they are actually doing, I would say, almost middle school-like algebraic work. And they did a lot of word problem solving, and we talked to them about common combinations of word problems. So I remember having conversations with Lynn, it's like, we've surveyed all these word problems, and which one of these do you think are going to be the most impactful for students? And so even though she was not a co-PI on this grant, she was always a partner in the back and someone I could call and talk to and run all of these ideas by her. But you can see, you cannot see, I'm sorry, it's so dark, wow. But students are starting to use a singular schema equation to represent these multi-step word problems. And we compared that to students who used multiple equations. So these students would be like, oh, it's a total problem and an equal groups problem. And they would basically solve the total part and then the equal groups part. And so we're really contrasting what this looked like for students. And so we actually are doing the data analysis as we speak on this project, but I do have some raw scores to share. And between both of the Pirate Math programs, we see comparable word problem gains, definitely compared to the BAU. The students who used 1 equation have a slight but not significant gain over the students who use multiple equations. So I'm really excited about the multi-level models that are going to come and hopefully answer that question as to which one is better, or are they both efficacious? And just as before, there's been a very large team that has been conducting this work. And again, very helpful, very thankful to the Institute of Education Sciences who did this funding. So that's all of my parts of thinking about quests. And so now I would like to turn our story to some voyages. And so I learned from what I would consider the best as to how to mentor doc students and how to build in dissertation projects into your existing larger studies. And so I'm going to share 3 of these. The first, which was conducted by Danielle Lariviere. She is starting as an assistant professor at Florida International in the fall. And she took Pirate Math Equation Quest and incorporated an aspect of math vocabulary into it, and that is called Vocabulary Voyage. And that is our tutoring team on the year in which we did this work. And so she kept a lot of the things very consistent that have been emerging from Pirate Math Equation Quest. Captain Cards is a fluency warm-up. Buccaneer Problems is where you learn about all those schemas. Ship-shape sorting is where you do a schema sort. We were doing that in 2008. We're still doing it now because it is important. But then she adapted 2 aspects of this intervention: vocabulary voyage and then the review, Jolly Roger review. Very pirate themed still. So Danielle was really interested, and we had so many conversations about, well, how important it is that students understand the vocabulary terms that are within these word problems. And this is not a keyword strategy here, but this is helping students deepen their vocabulary knowledge, so that helps them understand the word problems better. So she designed a lot of different activities for students to explore the definitions and meanings of these terms. Played different games with students, like memory matching games. They played a heads-up game for math vocabulary. And then every day at the end, not only did they have a Jolly Roger review that reviewed a word problem, but they also had a Jolly Roger review where they reviewed math vocabulary. And so what Danielle and our team learned is that with this Pirate Math Equation Quest, with the vocabulary voyage, on vocabulary outcomes, we significantly improved over students in the BAU, and we also saw outcomes that were really important for word problem solving. And this year of the study, we did not have that nice second active intervention condition to test Pirate Math Equation Quest with and without vocabulary voyage. And so that is an activity that actually Danielle's going to start undertaking next fall. So what we see from this is that it's really important to focus on math vocabulary. It does improve vocabulary outcomes, but future research really needs to investigate whether that vocabulary voyage component of Pirate Math Equation Quest is an absolute necessity within the intervention. But we move from voyages to beyond. So there's 2 other studies I'd like to share with you that still have at their heart that pirate math that was developed back in the early 2000s. And so this is a study that I'll share with you from Tessa Arsenault, who's one of my former students and now an assistant professor at the University of Texas, El Paso. And this is all about deck logs. And there's our tutoring team that helped on the project this year. So just as before, we kept a lot of components of Pirate Math Equation Quest the same, but deck logs is all about math writing. So we've got a little bit more writing here today, Kristen. And here we were really interested in whether we could use math writing to deepen students' schema knowledge. And so Tessa and I and colleagues developed this whole side intervention here around math writing. And the students were writing about, well, why were these problems a total problem, a difference problem, and a change problem? And it's really hard to see there, but one of these students says, I know this is a change problem, and I know this because there are children at the park, and then the number of children increases. So right there, we're seeing that they have a really good conceptual idea of what's going on in the word problem, and the idea was, well, does that help with their math writing, and does that help with their word problem solving? And so Tessa learned that Pirate Math Equation Quest with the deck logs leads to some substantial gains in students' mathematical writing. And we also see that it was also led to substantial gains in word problem solving. But this year we did have a comparison condition that did not do deck logs, and both conditions pretty much performed comparably on word problem solving. So I think that Tessa is really interested in looking into the future to see how much math writing intervention do students need before it actually leads to an improvement over regular Pirate Math Equation Quest on their word problem solving. And then there's one other study that I would like you to share that just got wrapped up, and this one is about poly problem posing. We like to name everything, and very piratey, as you can tell. And this was led by Allison Hardy, who is graduating in May from UT Austin and is going to start as an assistant professor at the University of Tennessee, Knoxville in the fall. And that's our tutoring team that conducted this work. And her big thing that she brought to Pirate Math Equation Quest was a focus on problem posing, which is posing your own word problems, and whether that is impactful for understanding word problems and improving word problem performance. So in poly problem posing, first, for students to write their own word problems, they have to know a lot about topics and categories. And so students use these different category and topic cards where it's like, oh, if you run a word problem about bugs, maybe it's about beetles or butterflies or ladybugs or spiders. And then students comprised their own word problems here. So they would first think about the schema of the word problem, think about the topic and the categories, and then they would write word problems like these. You can't see it. I'll read the one on the left-hand side. It says there are 14 ogres and 38 fairies. How many fairies and ogres are there in all? So you can see here, again, we're getting into that conceptual heart of these word problems and really helping students understand, well, that's a total problem, and how would you write your own total problem? And so students in poly problem posing, they outperform students in Pyromath Equation Quest alone and the BAU on lots of different measures of problem posing. And then we see a gain on word problem solving for poly problem posing, that's hard to say, against the BAU. But here we also see that poly problem posing, PMEQ with and without poly problem posing, they're performing comparably on those word problem outcomes. So I think the question is that an integral part of word problem intervention? And that is yet to be determined. So hopefully Allie and her future colleagues will be investigating that work. And so as I think about the work that was done down the hill from here and started by Lynn and some of us in the room, and then we've moved to quests, and we've moved to voyages, and we've moved to math writing, and we've moved to problem posing. And the thing about this is that the research does continue. And I think that what I think about in this room today, and I wrote it down, but the research continues not only with my generation of researchers, but the next generation of researchers. And they are all influenced by Lynn, and I think that I would hypothesize that their students are also going to be able to continue to do that research that's really influenced by Lynn and so many others. And so for that I can only imagine that teachers and parents and kids will continue to be influenced by Lynn for decades to come. So thank you very much.